trigonometric identities. We've been asked to prove this identity for any triangle. When we think about cos B, we might think about the cosine rule. Manipulating the cosine rule to express each of the sides in terms of cos of the angle, we would see that cosine A is equal to a squared minus b squared minus c squared all divided by minus 2bc. So that's just manipulating the cosine rule formula. So if this is true, what would cos of B look like? Now, just be careful about that the angle matches up to the particular letter that goes in the first position. So cos B would be b squared minus the other two sides squared divided by the negative 2 times the other two sides that aren't b. And similarly for cos C. So we could express cos B and cos C in terms of the sides in the triangle. Now let's look at the question we've been asked. So the left-hand side of our given term is c times cos B. So we have an expression for cos B here in terms of the sides. So I'll sub that in here. Take away b times cos of C. So we worked out an expression for cos of C. We'll substitute that in here. And we want to manipulate this to become c squared minus b squared over a. We will notice that c divides in above and below in the first term and b above and below in the second term. Goes in once. They have the same denominator, so we could write this as the first term, take away the second term. Be careful with the signs here. So it's minus c squared plus a squared and plus b squared. Just don't make a mistake with the signs. And this is all being divided by minus 2 times a. So there's some simple cancellations happening here. So what we're left with is 2 times b squared minus 2 times c squared all over negative 2 times a. Beginning to look like what the given expression at this stage. 2 is a common factor. So on the top we have 2 times b squared minus c squared. This has been divided by negative 2 times a. So 2 goes into 2 once. So it's b squared minus c squared over negative a, which will be the opposite of that over positive a. So we've proven what we set out to prove.